As I talk to more people about my book, White Flag, there's great interest in how brain chemistry is changed with substance use disorder, how epigenetics may have ramifications also to predispose people to substance use disorder. And although I go into it in some detail in White Flag, I thought it would be helpful to people to have an in depth conversation with an expert. And I'm lucky today to have one with me, Dr. Jared Schwartzer, who also happens to be my stepson. Let me tell you a little bit about Dr. Schwartzer. He is currently the director of the Science Center at Mount Holyoke College, an associate professor in the psychology department, and the chair of the program in neuroscience and behavior. He teaches courses in psychopharmacology and clinical neuroscience. He earned his Ph.D. in behavioral neuroscience at Northeastern University and continued his postdoctoral studies at the University of California, Davis School of Medicine. Thanks so much, Jared, for being with me today. I really appreciate it.
Judy, thank you for the invitation. It was such a joy to work with you as you developed the book, and I'm really proud to see it being released, and excited to have the conversation today.
Oh, thank you. So I'm going to start right in and ask you some questions, if that's okay. I think the biggest thing that people ask me is, what happens in your brain? What changes in your brain chemistry for drug users, for people with substance use disorder?
Yeah, I mean, there's no short answer because there's a lot that changes. I think the easiest way to start is to talk about the goal of the brain is always to keep itself in a steady state. We call it homeostasis, or always be balanced. And when you start taking pharmacology, whether it be a substance use or even over-the-counter medications that impact your brain, those drugs and medications have impacts on your brain, and then your brain responds by trying to change its own chemistry to adapt to it. So there's the immediate effect of a drug, and then there's the long-term adaptation that happens slowly. And so what happens with substance abuse is people are using these drugs regularly, and their brain chemistry is changing, their biology is changing, and the brain then tries to readapt to function as best it can in the new chemical environment. And because it happens slowly over time, addiction typically sneaks up on people. Nobody knows these changes are happening until they suddenly stop using the substance. And now the brain's in a state where it has changed, it's adapted to that change. And now it no longer has that chemistry it's been used to, which is the new chemistry with the drug in it. And you get what are called withdrawal symptoms, because now it's looking for that higher level of chemistry and it's not there. So people then tend to use the drug more to rebalance the chemistry.
Let me ask you a follow-up question is how does that affect behavior? The changes in the brain with substance use disorder, how will that affect someone's behavior?
All right, so there's two parts I want to talk about with that. One is the withdrawal, and the other one is the seeking of the drug, the kind of the reinforcing parts of it. So the reason people often may seek a drug out to begin with and continue using it is because drugs that have high abuse potential, drugs that are often associated with substance use disorder, have a particular effect on the brain in a pathway in the brain called the mesolimbic dopamine system. This is a bunch of neurons that release dopamine, and it's really talked about as kind of a neural price tag for how we engage with things in our lives. So when we eat fatty foods or see something that brings us joy, it's because our brain has put a high value on that. It's called valence. We value it as being positive. And that positive value happens on a neurochemical level by giving a little squirt of dopamine to say this is of good value. It's really important evolutionarily. We would find a piece of meat in the wild and go, well, that's going to be a lot of energy. Let's value that and try to find that again in the future. What drugs do is artificially increase the value. They cause that dopamine to be released. And so the brain begins to value seeking the drug out, because that's what the chemistry is doing. And even if the person knows, I don't really want these drugs anymore, their brain has put a positive value on it, right? There's a difference between the way the brain values something on a chemical level and how you intellectually value it. You might know it's no longer good for you, but the brain deep down has put a positive value on seeking it out, causing you to seek it out again and again and again.
Is that the reason behind when they say in some of the literature that you want to stop but you can't? Is that part of that equation?
That's absolutely it, right? So we think of our brains as one organ, but it's really many different circuits all working together And when all those circuits agree, we don't realize our brain is competing. But there's certainly experiments we can do that would demonstrate that different types of information are coming in and your brain has to decide what to do with it. And so you're always getting information about the value of something. You're also getting information about, say, the logic of it, what's socially appropriate in the moment, what's culturally relevant, what else is happening, right? I talk to my students who might be hungry during my class. Their drive is to go seek out food. That's the value. But the idea that it would be disrespectful actually overrides that. And what happens in substance abuse is that demand to seek out the drug because it's so valuable becomes so much stronger as a signal than the other part of the brain that's saying, but don't take it. And there was this wrong idea that maybe it was about willpower, but what we've learned from research is that the brain has a finite amount of energy, and if the appetite for the drug is so loud, even if you can logically know it's not good for you, that circuitry is so much stronger than your ability to say no, that you cannot stop yourself from taking it, because that circuit in your brain is really activating much more than the don't do it circuit.
But that takes away a lot of the stigma and the shame behind it too, knowing that there's a chemical reason that people may want to stop, but they're unable to, and they don't have the ability to. And what about reversing the brain chemistry, say when you use some of the medically assisted treatment like Suboxone and buprenorphine and methadone? Does that help to reverse that kind of brain chemistry? How does that work?
Yeah, it's a good question. And this kind of speaks to the other part I mentioned about the other piece of the circuitry, which is the withdrawal. So one part of seeking out a drug and again and again is that the value system. But the other part of that is the consequence of not taking the drug. If you've gone so long to adapt to a lifestyle or a brain chemistry that has the drug on board, when it's not there, you feel the extreme opposite effect. So for opioids, for example, they provide euphoria and a kind of a calmness, and then you take that chemistry away, and now you have a dysphoria and an anxiety, a hyperarousal state that's very unpleasant. And so some of that seeking out the drug is to actually provide the chemistry you need to function at an appropriate level to not experience those negative effects. What drugs like Suboxone and methadone, what they do is not change your circuitry. They just provide enough of the chemical so that those side effects or those withdrawal effects are not present so intensely. And this is kind of a critique of these as treatment methods. They're certainly a component of opioid addiction, but they then in and of themselves are not going to reverse the chemistry because you're still giving yourself opioids. One method is to take methadone or Suboxone and slowly over time reduce how much you're taking to kind of wean you off slowly. But substance abuse disorder is much more than quite simply a chemical imbalance. There are differences in the circuitry in your lifestyle. The best treatment approaches use what's called the biopsychosocial model, where we're looking at the underlying biology, the social factors that led you to the drugs in the first place, and what psychological factors that need to be addressed. And so methadone-assisted therapies like Suboxone and buprenorphine are really one piece of a treatment plan, but in and of itself are not going to be a solution to substance use.
And they're not the things that will lead to reversing the brain chemistry, is what you're saying. Also, not that they're not valuable, not that they're not a valuable tool, but you're also saying, I think, that you can have an effect on reversing it over time. Yeah. Is that true?
Yeah. So certainly you will change brain chemistry with methadone. That's the intention of it. But the circuits I'm referring to, where when you're dependent on a substance and you have a strong appetite for it, particularly during stressful events, or you see a cue that kind of reminds you of it, those circuits are much more complicated than adding some chemistry to it, right? We're not only changing chemistry, we're trying to rewire the brain. And that is a much more difficult task to do.
Right. And that's, as you said, refers to therapy and other methods certainly this is only one piece of it, but it's a complex piece and something that people, want to know about and understand a little better. I know we've been talking a little bit about it too, about how those changes can happen. Can you say a little bit about how epigenetics might predisposed, I can't even say that word. What's wrong with me?
Predisposed.
Predisposed people
Yeah.
to substance use disorder. I mean, that's the confusing piece for people.
Yeah, or the frightening piece, right? If you know you've got substance use disorder in your family, are you destined for it? Well, let's start with the basics, which is where do we come up with the knowledge that genetics play a role? We look at twins, identical twins, fraternal twins. Identical twins share the same exact genetics. And if it was a purely genetic disorder, then every identical twin and their pair would have substance use disorder. And we don't see that. We see a lot of overlap, but we see that genetics alone don't explain all of why someone succumbs to substance use disorder. There are certainly a large list of genes that we know could be implicated. Some of these genes work to make the chemicals you take more kind of sensitive to, your brain becomes more sensitive to receiving those signals, or less sensitive, which would be protective. But so much of it too is environmental factors. When we talk about brain circuits, your brain as it develops creates circuits that make you more or less susceptible to to substance use disorder. And the brain is in my opinion, a brilliant organ that has all sorts of redundancies to it. And what happens is maybe you've got multiple circuits that can all compensate for one another. But now you have a genetic mutation that makes one of those circuits far less able to do its job. So that's kind of one hit on the brain. And then you have an environmental trauma, maybe as a child, and that weakens another circuit. And so as you're whittling away at these circuits, you've got fewer compensatory mechanisms to help protect you against something like substance use disorder. So the idea of looking at your environment and that being a risk for the drug is also a part of it, right? So why do people seek out drugs to begin with? Are they seeking the chemistry that they don't quite have? Are they not dealing with stress in an appropriate way, or is it difficult for them to cope with the stressors and this becomes a tool for them, self-medication? And so those environmental reasons could actually impact why they become dependent on it, why they're using the drug in the first place.
And with epigenetics, and trying to understand that, is that something that can be passed down through generations or through your family?
Yeah.
And how does that work?
Well,
I'm sure that's not an easy answer.
Yeah, I mean,
I know.
and we can talk about epigenetics in a moment, but it's not just the epigenetics; it's the family culture, it's the social factors, right? That whatever ways families have dealt with some of their challenges, oftentimes gets passed down to the next generation. Whatever social factors, socioeconomic status, that oftentimes passes down as well, given our societal structures, and so those environmental elements are also part of the family line. But in terms of epigenetics, epigenetics is this fascinating idea that it's not just whether we have the gene or not, but whether that gene gets expressed. And so, I think about our DNA as being a giant ball of yarn, but at all different parts of the yarn, it's wrapped up into little balls. So you've got little balls of yarn, and that's helping the DNA get packed into a cell. And between each ball of yarn is an open strand of DNA. And that's what's getting read. And what happens is, as you have environmental factors, you have a stressor, you've got a good experience in your life, it actually causes these balls to either roll up or unroll, exposing other genes. And so you could have the gene that makes you susceptible to substance use disorder, but given the epigenetics that were either passed down to you or the ways you went through your life, that's changed how these balls get rolled up. And it could, say, cover up a risk gene or expose a risky gene. And what's fascinating about epigenetics is the instructions for how these balls of DNA get rolled up, they get passed down. So it's not just the genetic material, the actual gene, but the instructions for when you should have a gene available to be read and when you should keep it hidden. That information gets passed down as well. So that would be the epigenetic.
That is fascinating. Passing. That is fascinating. Yeah. And from our talks, previously, you said that's not like written in stone. It's not something that you have no ability to change. It's something that you do have ability to change, and being aware of it might be the key, to doing something. And is it lifestyle changes? Is it possibly therapy? Is it what kinds of things can undo those balls of yarn differently?
Yes, all of it. What got me so excited about epigenetics is, through my education, it was the argument of nature or nurture. But epigenetics is this linchpin or that links an explanation for how the environment could translate to a biological impact on you. So every experience you have has an epigenetic consequence. Our brain's ability to learn, that dynamic ability, is because of epigenetics, because we're constantly controlling what genes we change. And so I think that gives everybody some hope, right? That our brains are not static, that there are certainly therapies and treatments that give hope, and there's some new pharmacological ideas that are coming through that might be worth looking at too. Some revolutionary and controversial ideas about how to make the brain more what's called plastic. Plasticity is this term for how easily the brain can adapt and rewire. And certainly with substance use disorder, it gets the circuits get so ingrained that your brain becomes so much less plastic, so much less able to rewire. As you get older, your brain is much less plastic. And so are there ways that we can kind of reawaken those circuits and make them more malleable like they were when you were a child first growing up?
Mm-hmm. And the idea behind brain chemistry changes and epigenetics, I mean, does that also lead into understanding why trauma has an effect on
Yes.
people and possibly substance use disorder? That both of those things, either, trauma in their lifetime or being passed down from, their parents, something happened.
Yeah.
That might explain that a little bit more too. Is that true?
Or a lot bit more, right?
Yeah.
So childhood trauma is, I say childhood in particular because during this time when your brain is developing, it's constantly trying to rewire itself to accommodate whatever environment it's experiencing. So you have one or multiple traumatic events, and the brain begins to adapt to a lifestyle where it's trying to deal with those traumas and wire itself in a way that it thinks it's preparing itself better for trauma. But there are consequences to that adaptation, some of which becomes higher susceptibility to substance use disorder. So when we think about the impact of trauma, epigenetics is one way to explain it, and it's just one kind of molecular or biological mechanism. But the other one is, how do those life experiences change the way your brain wires, right? The circuitry level idea, so that you're more susceptible to it. Trauma absolutely passes down, and one of the areas of my own research is to look at how maternal trauma can actually inform the developing fetus's brain to be prepared for a world of an intensity, because that's what it's sensing. So during development, if the pregnant individual is experiencing trauma, the fetal brain is getting a sense of those signals, saying, wow, I'm about to be born into a world where there's a lot of trauma. I need to wire my brain and prepare myself biologically so I can face that. And in doing so, it's already preparing and wiring itself for a lifestyle that it may or may not experience, and that's setting it up, to adapt well or not well to those experiences later on.
That is fascinating. And does that, what I've read about is cortisol and how that can impact a fetus.
That's right.
Which is, produced more under stress situations.
Yeah.
And is that part of what you're talking about too?
Yeah. Cortisol is one of the major measures of stress, and cortisol is a wonderful chemical that really is important for regulating our stress. One of the challenges that we have is cortisol was designed to help modulate your fight or flight response. The only biology we have for extreme events is this fight or flight response, because when we were pre-civilization, we had to outrun a bear, and so we needed to get our hearts going and get our blood pumping and run away. Most of, or a lot of what we experience now are psychological traumas and psychological challenges, but our brains don't have a biological mechanism for dealing with psychological stress. We only have the one biological mechanism. So every time you undergo psychological stress, you have this large biological response, which is causing you to, creating a reaction, which is to run away and to be active. And those chemicals, cortisol being one of them, are being released for you to deal with a situation that doesn't actually match the psychological stressor you're in. And so that's where the stressor and the biological response don't match up, and the developmental consequences are not appropriate, because it's not really the sort of response you need for that type of psychological stressor.
And all of this whole conversation just leads me back to the fact that this is a complex issue. It's not one thing. It's not even two things.
No.
It's very complex, and I think it helps people understand what they're dealing with when they have a loved one who has substance use disorder, and they get frustrated with trying to help them. and not knowing exactly what to do. It is very complex, and they need help to understand it.
Yeah.
And I think this conversation is helpful to that end. So, is there anything else you could add that might be
Yeah, I
helpful for
want
people
to,
to know?
thanks. I want to go back to the idea, and your book does it so well, of destigmatizing this. When we think about other organs in our body, if our pancreas no longer is creating insulin, we go, well, you need to get some support for that, right? Or if your leg breaks, we need to worry how to mend your leg. Your brain is just another organ in your body, and if it hasn't wired correctly, we need to get you some help and support to help create help your brain develop in a way that's much more adaptive to you, right? And so part of what we need to do is recognize substance use disorder as a mental health issue, as another biological factor that we all want to be compassionate and considerate about supporting, no different than any other organ in the body.
That's great. I love that you said that, because that's, what I'd like to have people change their perspective in looking at people with substance use disorder as if they have another disease like diabetes, as you said.
That's
So,
right.
so thank you. Thank you so much, Jared. I really appreciate it. And it's great to be able to talk to you about this stuff. And I appreciate all your help.
Thanks
Thank
so
you.
much. And congrats again about the book. It's fantastic.
Oh, thanks so much. Okay. Bye.